Hi, I'm Benny D, and in this video we're going to be looking at populations and samples. So, the set of all eligible members of a group we intend to study is called a population. Okay, so quite simply we could be talking about the population of Australia. So we might be wanting to study the population of Australia. So for our statistics, that would be our population. We could be looking at studying Year 12 students. Okay, well, our population then would be all of our Year 12 students in the country, or it could be smaller than that. You might be wondering about Year 12 students that are studying math methods. Okay, well, our population would be all the students in Victoria studying math methods. Okay, a subset of that population is called a sample. Okay, and often, it's not practical to study an entire population. Okay, for example, if we want to study everyone in Australia, well, there's just too many people. Okay, so what we want to do is take a sample of that, so a smaller sample of that population. So a simple random sample is a sample of size n, where every sample of size n has the same chance of being selected, and every member of the population has the same chance of being selected. So essentially, for a simple random sample, what you want to be doing is randomly selecting members of the population to create your sample. Okay, but in doing that, okay, we need to be careful, because in order to be able to make valid conclusions, our sample should have the same proportion of subsets as the population does. So what we mean by that is, if in our population, for example, we have, say, 50% male and female, for example, but when we randomly select our sample and 75% of our sample are, say, males, and only 25% are females, okay, well, we can't really draw valid conclusions based off that. Okay, so good samples, okay, will mean that if there is, say, subsets of, say, males and females, or ages, or something like that, the proportion that they occur within the population will be held as with the same proportion in our sample. So, i.e., 50% males and females are in the population, so our sample is going to be 50% males and females. Okay. Our population proportion, okay, is called P, and it's equal to the number of people or the number of things with a certain attribute over our total population. So, for example, if our population was 100 people, 50 of them are male, okay, then our population proportion, P, is 0.5, because it's going to be 50 over 100. Okay, and this is also, so this population proportion, okay, is a constant value. Okay, it's fixed based off our population. Whereas our sample proportion, P, it's got a little kind of like a triangle up here, a little arrow above it. We call it P hat, is the way we read it. And that's our number of people or things with a certain attribute over our sample size. And this is called our sample statistic. So for those valid conclusions to be made, we really want P to equal P hat. Okay, that means that we're going to be able to make the best conclusions about our population based on our sample statistics. Okay, is when these two things are the same. Is it always going to be the same? No. Okay, even when we take a really good random sample, we have really good things in place, we may end up not having the right, the same sample proportion or sample statistic as our population proportion. So we need to be careful around that. Okay, you are able to randomly generate numbers of on your calculator, like a list of numbers, setting your different parameters. It's a little bit different on the Casio to the TI Nspire, so just check out your textbooks for how to do that, but that's a really good way of randomly selecting things. Okay, that being said, when you think about a calculator and a random number generator, it is still an algorithm that is generating numbers, so it's still not technically going to be a truly random sample. Okay, things that are going to be truly random samples are if you are rolling a dice and the number coming out, okay, is how you're selecting people, or you got everyone's name in a hat and you're randomly pulling a name out and that's going into your sample. So those type of things that are truly random are the best ways, but we can use software, very sophisticated algorithms, to do a pretty good job for us as well. So look, there's not too much to do with this. Okay, it's around getting your head around the terminology that you're going to see in this area of study.